But one thing I want you to be sure that I included in your exam is a question that involved Newton's third law in some way. And so this question doesn't really involve Newton's third law, not directly in a very recognizable way, but a situation that you have seen, which does involve Newton's third law, is a setup like this one. I guess I'm skipping this. Setup like this one, where you have multiple blocks connected by some string. Then this is where you do have something that's similar to action-reaction force pairs, and you have to have a very clear way of thinking about how those two different, how those blocks interact. The nickname I like to give to Newton's third law is the law of interaction. It's the law that really describes how two or more objects interact with each other, so that really the thing that you have to distinguish here is that the force that I'm applying, it applies only to the rightmost block. It only applies to M3. Then as a matter of having complete mechanical theory of universe, what you have to figure out is how does M2 and M1 move? And on the flip side, how does having M1 and M2 affect the motion of M3? And the way we do that is through Newton's third law. And a setup like this can illustrate that consideration fairly well. So let me just do that. I think I can do that in 10 minutes or so if I'm just doing part A. So if there's no objection or question, let me at least do the part A, and then I'll see if I want to do more than that. So I have three objects. That means I need to draw three free bodies, or three free body diagrams. Let me call this M1, M2, and M3. And I think in the homework question you had these blocks dealing with some friction. But for this question at least, I'm not saying for your exam whether it'll be one way or the other. For this question, it says neglect any friction, so I'll neglect the friction. And that also means I'm just gonna ignore vertical forces, because the normal force really only becomes interesting when you have friction to deal with, and I don't here. So I'm only going to draw horizontal forces that will make it go a little bit quicker. So let me start by just drawing all the forces. I like to, so even without gravity, I like to draw forces that I know I have to draw. So let me start out with F3 on M3 here, not F3, F on M3 here. And I just want to emphasize, this is the only place where I draw F. The applied force F, it acts on M3. It doesn't act on any other bodies directly. And free body diagram only indicates forces that are directly acting on. So that's it. That's the only place where I'm going to draw F. Now, as I look at this picture, think about this setup, I ask myself the same question I always ask. Have I drawn all the forces? Then as I look at this string, I realize, oh, I need the tension force coming from that string. So let me draw the tension force there. Since it's a string 2, let me call that T2. So there's T2. Then I ask myself this question, have I drawn all the forces? As far as M3 goes, that seems like it. I don't see any other force that should be there. So I'm done with all the forces on M3. And I guess you can go a couple different ways. You can just look at M2 and M1 and try to think about what forces should be there. That's probably the way most people will go. So let me do it the other way. I'll do it through the Newton's third law check. Since this situation especially has three objects, it's especially important that you do this check and make sure all the internal forces have a reaction force labeled. So this apply the force F, that's external force. I don't need the reaction force to that. So for this force T2 from string 2, you think about the reaction force to this T2. So I guess technically the reaction force is on the string, but I'm not drawing diagram of the string. And really all that the string is doing is kind of allowing these two sides to interact with each other. So the reaction force is on this side here. It's on M2. So I should have a force on M2 that's equally magnitude and opposite in direction. So now I have a force on M2, which is going to cause M2 to accelerate. Then I once again ask myself the question, have I drawn all the forces? Then I hope you see that you have this string here too. So there should be T1 here. Then going through the Newton's third law check again. This kind of check and constantly asking yourself, have I done everything? It's an iterative thing. You keep doing it until the answer is no. You have remembered everything. Everything is perfect. Nothing needs to change. Until you get that answer, you keep doing that check. So doing that check, you get one more thing, T1, that's acting on mass M1. And you still do that check, have I drawn all the forces? And as you do that check with M1, M2, M3, now you should get the answer that says, oh, you've drawn all the forces that are in the horizontal direction. Yeah, so that's the free body diagram. And I guess that sort of, unless there are questions or requests, I think that's where I'll stop. In part to be really the main thing that you have to remember is make sure you remember that all blocks accelerate together. And that that fixes what the tensions T1 and T2 have to be so that all blocks accelerate together. And yeah, I think part B is fairly easy to do here. And parts, yeah. So I guess I don't want people to focus on minutiae. It's more about, do you understand how to set it up and how to analyze it so that I can give you infinite different varieties. I think I've given a version of this question where things are hanging vertically, and you've had in your homework where there were frictions. So, but once you remember to, once you know all the steps you need to go through, then you can adapt to any changes that I might throw.